Right, welcome to my video again, and in this video what we're going to be looking at, we're going to look at the nomenclature of the other derivatives of organic compounds. So we spoke about the hydrocarbons and we gave you the three types, your alkenes, your alkanes, and your alkynes, and we actually gave you how they are named. So today we're just going to look at the naming of the other compounds of the organic substances. So the different homologues that we're going to look at the functional group, and then we're going to look at the ending and how the general names of those substances would be given, right? And then we will also give you the structural formulae of the substances. So the first one, we're going to look at your so what we're going to label here is the homologous series. We are then also going to look at the functional group. We will also look at the suffix of the name. Of how it ends, and then we are also going to look at the molecular or structural formulae. And then we're going to look at the molecular formula of some of the examples of those homologues that we will be looking at. All right, so the first one that we're going to look at from the derivatives are your haloalkanes. So your haloalkanes have got a halide group that is attached to the organic molecule. So in other words, what in the naming of these, it's just called a halo. Whatever the name of the halo that you'll have. So if it's chlorine, you'll have a chloro. If it's a bromine, it will be a bromo. If it's a fluoro, iodo, etc. That is the so that will be the suffix, and then the name of the alkane. Right? So it will be that halo and then the alkane name that will be there. So if you've got the structural formula, you would have your carbon group, and then from there you would have your X compound, and then from there you would be able to name the substance as it is. So this would be, if it's chlorine, that would be your chloro ethane. And then in this other one, so the formula would be your C2, and then your H 1, 2, 3, 4, 5, H5, and then the X. So an example that we have, if let's say we've got your X here being the chloro group, and so what we're going to have is you'll have chloroethane, and therefore the formula is going to look something like that. That's an H, another H, H, H. Remember, the carbon maintains its tetravalency, and therefore you must always ensure that you've got 4 bonds around each carbon. So in this case, you're going to have C2H5 and then the Cl. The second example of the naming that we would like you to have is your alcohols. Right? The alcohol group has got the hydroxyl group, the OH group that is attached to the alkyl. And the suffix is anol. Whatever the substance will be, it's anol. And then from there you are going to have something like, for example, with an example, let's say you've got ethanol, right? So the ethanol would look, it will have 2 carbons, and then on the carbons, on one of the, so we will have something like that. On one of the carbons, you are going to have your OH group attached, and in this case, it's attached to carbon number 1. So this is going to be 1-ethanol or ethan-1-ol. And this is going to look, so it will be CH2OH, or, or easier still, CH, just write it CH3, CH2, and then OH. So, or basically, you know, with the ol, maybe if we just put it there so that when you start putting the position, it becomes a lot clearer. So it's just going to be your ol, right? So it ends with the ol. And another example, let's say you've got something like butan-1-ol, and so that means what that means is the functional group is found on carbon number 1, and if it's on carbon number 1, you would then represent it as having your 4 carbons. So there's your 1, 2, 3, 4, and then if you've got your OH there, and you would have something like that, count that around each carbon you have a tetravalent arrangement. Right, so in this case, this becomes carbon number 1, and that's carbon number 2, and then counting from right to left, and so this is going to be your butan-1-ol. You could have another one which could be butan-2-ol. Right, so your butan-2-ol, it means that the carbon, the functional group is now on carbon number 2, and then you've got that form of the isomer, which is a position isomer, meaning say where is the functional group found. So in this case, you would have your functional group on carbon number 2. So decide which one is going to be carbon number 2. And so if we have it in this case, it's going to be here. So if you're drawing the structural formula, you need to show the bonding that is taking place. All the bonds need to be shown, right? And therefore you would have it look like that. And take note, it's the oxygen that bonds to the carbon, because oxygen is divalent. In other words, it can form two bonds, and you can't have the hydrogen here first and then the OH. Even here, when we did that, it was that bonded to the carbon is the oxygen, then the hydrogen, because oxygen can form two bonds and hydrogen forms only a single bond. So you can't change that and assume that it is correct, because it is not, right? So there you are. And then in this case, again, you would write your condensed formula as CH3. Oh yeah, here I represented the condensed formula, whereas I want the molecular formula. So sorry, this is the condensed formula. The molecular formula is how many carbons? You've got two of them, so it's going to be two carbons, C2, and then how many hydrogens do we have? We've got one, we've got five, six, C2, H6O. And then in this case, it's how many carbons do we have? One, two, three, four. We've got four carbons, C4. How many hydrogens? Three, four, five, six, seven, eight, nine, 10. H10O. And then in this case, it's still going to be the same as the other, right? So basically, that's how you would show you represent your oxygen, your alcohols, as a functional group, a homologue. And then it's important that you always count the number of carbon, number of atoms that are bonded around each carbon or around each element or atom that is participating in the bond. The next homologue that we want to look at is your aldehyde. The aldehyde has got a carbonyl group which forms the functional group on the compound. Now that carbonyl group is terminal. In other words, it is on the last carbon of the chain. And the name or the ending of the name of the aldehyde is anal. It ends with anal. And so if you have an aldehyde that is made up of one carbon, so it will be a COO, and then you've got an H, and then the other part is also going to be an H. So this here is going to be your methanol. Right? And this is CH2O. Right? And then the other example that we can give is this. You've got a C, and then another C, and then O, and then you've got an H. Count 1, 2, 3, 4, and then 1, 2, 3, 4. And this here, again, the ending is going to be, so it's 1, 2, so it's Eth, and then the ending ethanol. So it's going to be ethanol. And this should have been, apologies, this should have been, oops, I must just delete that. So this should have been here, two carbons, double bond, that's a carbonyl group, and then it's terminal, last carbon, and then the chain. and then again it's going to be C2H 1 2 3 4 H4 and then O. So that is the other one, and so you can practice by giving us the name of, or giving us the formula of the following heptanol. Give the name and the formula. We've given you the name, so we'd like the structural and the molecular formula of heptanol. So this is practice. And also maybe pentanol. All right, so those are practice exercises for you. The next functional group that we are going to be looking at is your ketone. The ketone has got a non-terminal carbonyl group that is attached to it, which is also referred to as the keto group. Right? This R and R prime, these are just chains of these are alkyl chains, and therefore to show you that it is non-terminal, right? And the ending is unknown, right? And therefore we could have something like your pentanone, e.g. pentanone, if we've got an example control. Pentanone, we could have something like this, double bond there, and with the O, and then from there, this is the rest of the alkyl chains that we're talking about. These alkyl chains can be different or they can be identical. In other words, this can be longer and that can be equally long, or if not shorter, right? And so you've got your pentanone, and then the other one, so the molecular, the formula would be C3, and then count the hydrogens, 1 2 3 4 5 6, H6, and then your O. So C3H6O, and that is an example of a ketone. So you can give us the formula. This is not pentanone, this is propanone. Apologies. This is propanone. What I drew, I ended up drawing propanone. So what I would like you to do is to give us the structural formulae of the following. Give the structural and molecular formulae of the following ketones. Pentanone, and butanone. Then after that we have got carboxylic acid. The functional group of your carboxylic acid is the Cu group, which has got that, and at this point you've got an alkyl or a hydrogen, so an alkyl chain, and then that is your Cu group, right? And with your carboxylic acid, it ends with ilic. Basically, it ends with oic rather than ilic. Ends with an oic, ethanoic, and for example, if you've got methanoic, ethanoic, propanoic, whatever, so it ends with an oic. So if you've got something like with two carbons, so you've got that, and then two carbons, right? And so you are going to have something that looks like this. So there's your functional group, and then you know that you are dealing with something called two carbons, so it's ethanoic. So it's going to the ethanoic, let me just write it here, ethanoic acid. And so the formula would be C, two carbons, so it's C2, and then how many hydrogens? 1, 2, 3, and then C2, H4, and then O2. So that is your carboxylic acid. So you could also give other examples, or you give us the structural formula and the molecular formula of the following acids: propanoic acid and methanoic acid. Right? So that is another homologue that you guys must be aware of. So now when you look at this, we have looked at how many have we referred to? We've referred to one, your haloalkanes. You've looked at your alcohols, you looked at your aldehydes, ketones, your carboxylic acids. And so now the next one that you're going to be looking at is your esters. Right? Your esters are sweet smelling substances which are made from a reaction between a carboxylic acid and an alcohol. Right? So your carboxylic acid have got the following, the ester link. So the functional group that you're going to get is going to be, you've got a carbon, it's got an O, and then you've got an O in the middle, and then you've got a chain, and then on the other side you've got another chain. So this here is the ester link. Very important that you pick it up and that you're able to recognize it. So that is your carboxylic acid. So here there would be a carbon, as there would be another one here. So if, what do they end with? So the name, they are a salt. So they will end with an O8. So it's a combo from the acid, from the alcohol, and from also from the acid itself. So if you have an ester that is formed from the reaction between a carboxylic acid, let's give an example here. The carboxylic acid is going to be ethanoic acid, and then the alcohol, let us call plus methanol, right? When you name the ester, the first part of the name comes from the alcohol, and then and that becomes an aisle, so it becomes a radical, so it becomes methyl, and then the rest of the name comes from the carboxylic acid. So in this case, if you have your ethanol, your methanol has got this formula, and then that methanol reacts with the ethanoic acid. I'm just going to write it this way so that you are able to observe what then happens in the reaction. Right, so during this reaction, the OH comes from the acid and then the H comes from the alcohol. So this part of the molecule is going to be removed, and then the two molecules join up, and you will get the compound ester that's going to be formed. So that water is removed as H2O. So the product that you're going to get is going to be you're going to get your CH3. So from the part that's coming from the alcohol is going to be the CH3 as well as the oxygen, and then it combines with the the part that's coming from the carboxylic acid. So from the carboxylic acid you get that carbon and then the double bond and the rest of the alkyl chain that is there, right? So count the number of carbons. You've got the one from the alcohol, and then the two from the ethanoic acid, and then from there, this is where they combine. This is the ester link, right? That gives it the name. So the name, the first part comes from the alcohol, and that first part is going to be your methyl. Got one carbon, so it becomes your methyl, and then the second part is the salt part. Remember that part, it's got two carbons, so it's going to be so it's going to methyl ethanoate, because it's now a it, the salt of it that's been formed. So methyl ethanoate, so that becomes the ester that has been formed. And then there's also going to be the water as well. It's a product that is made. Remember we said when it reacts, the water molecule gets eliminated. So that's one of the other products that is formed. All right, so very simple, very straightforward. Remember that the first part comes from the first part of the name is from the alcohol, and then the second part is from the carboxylic acid. All right, thank you, and I hope you enjoyed this video. And if you did, please share, please like, and subscribe to the channel.